So welcome everyone to the Advanced Materials Showcase. We're really excited to have you all join. To start off quickly, here's our agenda. So we're going to have two sessions, and the sessions are going to be pretty quick. So for the first session, I believe we only have 4 companies. For the second session, 5 companies, or maybe also 4. But right now we're in the middle of the opening remarks. So to give you a little bit of background on Deep Tech Showcase, if you've never been on one of these calls and never heard of this or seen this, what Deep Tech Showcase is we're a community or an ecosystem that's trying to bring companies together with the right stakeholders that can help them get to the next stage, get to the next level. So we're using these platforms in order to help expose, the general public to more technology. And so within the ecosystem, we have here we break it down and make it real simple, but basically startups that are looking for connections, funding, government relationship, etc. And then on the flip side, we have both government and corporate tech scouts and investors. So anchoring all of this are our events. You're on one right now, believe it or not. And at the events, we have the companies present. Usually the pitches are about 5 minutes long, followed by a 5-minute Q&A. Today, because we have a pretty good lineup. We're probably gonna. It might be even 6 minutes for some of them. So sit tight. Don't worry. If your watch says 5 and it's at 6, it's intentional. It's not a mistake. But each month we have a different showcase, and so this month is advanced materials. Next month is going to be energy, and there's going to be a slide on that. So hang tight. And then in between the showcases, we do guided introductions, and what that means is we essentially matchmake. So if you are an investor or a government representative or a corporate representative or a startup even, and you're looking for relevant companies in your field or relevant companies in a certain area, we're always happy to help find relevant companies with the right tech and bring it together, because our goal is to see this tech really flourish. So we don't want it to be a situation where it's great tech, but it was undiscovered and things went out of business, and now it's really hard to get it going. Rather, we want to take advantage of the opportunity. The companies that are working towards raising right now, the companies that are working towards relationships right now, and give them the floor and the stage. All right, so I mentioned really quickly the energy showcase. So in August, we have the energy showcase. After that, we're going to have the autonomous systems showcase. So feel free to register for both of those after this. And now we're going to have David Fertig from Eagle Point Funding briefly tell us a little bit more about Eagle Point Funding and what they're doing and what they're up to. David, the floor is yours.
Hey, Asher, thanks so much. So Eagle Point Funding is a non-dilutive grant consulting agency. We help companies access federal funding, and we do that both in the form of SBIR grants, which is Small Business Innovations and Research, as well as BAA grants, or Broad Agency Announcements. And as part of that, we also use our network to run events and make connections between relevant stakeholders and companies through the Deep Tech Showcase, which is exactly where we are now. So the federal government is usually looking for dual use technologies, so anything that can solve a government need as well as be useful in the private sector. And if that sounds like something your company is doing, I would love to get on a call with you to discuss how we might be able to help you access the billions of dollars available in federal funding. So if that interests you, please scan the QR code and book a call with me, and I'll hand it back to you, Asher.
Thank you so much. I like it. I like it a lot. Yeah, and if you're not fast enough with the QR code on your phone, don't be shy. Let me know. Feel free to email me, and I will be more than happy to set you up with David. Not an issue, because I know I never catch QR codes. Just on a personal note, just to let you guys know. So without further ado, we're going to talk a little bit about the sessions. So session 1, we're going to be looking at Maverick, Biometals, Dasco, and Jaeger Tech. Session 2 is Satex Technology, Intrepid Automation, Alpine Advanced Materials, and Inkbit. All right, so what I'm going to do now, because we do have a little bit of time, is I am going to introduce the panel. So I'm going to stop sharing. And when I call your name, feel free to tell us a little bit about yourself, what you're looking for, what you're interested in, and what you're expecting from this showcase. And so let's start with Kathleen. Kathleen, go right ahead.
Hi, I'm Kathleen German. I'm with the with Dow Chemical. I'm with our corporate venture group. My role is a tech scout based here in the Bay Area, California. And Dow is it's a global producer of advanced materials and chemistry. We're interested in the latest topics of the 21st century. So circular economy, including circular plastics, bio-based materials. And so for us, we're a strategic group. We don't have a set fund, but we're looking for the match with any of our Dow businesses or our business strategies. I'm happy to be here.
Perfect. Thank you for being here. We definitely appreciate it. Next, we have Gerald Wang. Gerald, do you want to go right ahead?
All right, great. So hello, everyone. I'm Gerald Wang. So I'm from GC Ventures America. So GC Ventures America is the venture arm of PTTGC, so which is a Thailand headquartered petrochemical company, and our revenue is about $20 billion. So we are very interested in anything related to polymers, like recycling, composite, coating, 3D printing, and etc. So great to learn more from the startups here, and look forward to the discussion.
Perfect. Awesome. Thank you for being here. Carolina, you're up. If you're, yeah.
Yeah, sorry, you caught me in between pit stops, so I'm dialing in from my car. Thank you for inviting me. My name is Carolina. I am based in London. We are a VC fund called Starbeam Capital. We do invest in deep tech and climate tech solutions, specifically advanced materials and enabling technologies are of big interest to us. Thank you.
Perfect. Thank you for being here. Maureen, you're up.
Hi, everyone. I'm Maureen Rinkunis, or you can call me Mo as well. That works. And I wear a lot of different hats. I'm an entrepreneurship educator. I am an angel investor, and I help connect corporates and startups in the food, materials, and broader climate tech space.
Perfect. Perfect. Thank you for being here. Han, you're up.
Hello, Han Ko. As you can tell, mine is pretty simple, right? Anyway, USACO Group is my company. We are basically a VC firm. We operate in USA, but we have office all the way to South Korea. So we have a pretty strong relationship in the South Korean market. We have presence in Los Angeles, the Midwest, and then New York, of course, and Texas. Our interest is in deep tech and AI and other multiple areas of state arena. And what's unique about us is that we invest in mostly about 70% U.S. companies, but about the rest of them we really invest in companies from all over the world. So we actually have a very international, I guess, background effort in the arena. And also, I just want to add that it's always a pleasure to be a part of deep tech, and then also I recommend Eagles funding as well. Thank you.
Thank you. Thank you for being here. Perfect. Next up, we have Julia.
Hi, everyone. I'm Julia Davory. I'm based in San Francisco. I work with PVP Seed Fund. So we're a seed fund. We invest at the convergence of fundamental technologies, chemistry, biophysics, as well as AI and data, with a focus mostly on health and sustainability.
Perfect. Perfect. Thank you for being here, Julia. Next up, we have Gus. Gus, you're up.
Hey, everybody. I'm Gus. Originally a scientist and engineer by training, did a PhD and all that jazz, ended up on the venture capital side. I'm at Boost VC, where I'm one of 3 investors here. We're investing out of Fund 3, which is a $100 million fund, which we invest in early stage deep tech. And I say deep tech very broadly, anything with really exciting and awesome innovation, we are more than happy to touch. And we like to be as early as possible investing in companies. And we're based in California.
Perfect. Perfect. Thank you. Thank you, Gus. All right. Next up, we have Jonathan Wu.
Hi, this is John from ITIC. ITIC is the venture arm of ITRI, which is one of the largest research organizations over Taiwan. And generally, we focus in deep tech in general, and also in the joint venture with Applied Materials. So in that one, we particularly focus in materials and display and also semiconductor equipment area. Thank you.
Perfect, perfect. All right. So that's everyone. That's everyone for now. We might introduce a few more when they join. But without further ado, we'll have the first company present, which I believe is Maverick Biometals. Whenever you want, you can begin sharing your slides and just get going.
Awesome. Thanks, Asher. Hey guys, I'm Jesse, co-founder and CEO of Maverick Biometals. Let me get my screen up here. Can you see my screen?
Yep.
All right, awesome. So at Maverick Biometals, we are expanding metal production through biology. The shift from fossil fuels to renewable energy sources is also a shift in the demand for metals. Right, we'll need more lithium and other metals to supply our EVs, our batteries, our magnets, everything as we transition to green renewable energy sources. Now, the traditional process to extract metal from rock is very energy intensive and inefficient. It's done in a big machine like this called acid roasting. You take all that rock, you use natural gas or coal to heat it up to 1,000 degrees Celsius for a few hours, and then you dump in a ton of sulfuric acid, and that leaches out some of the metal. And then you're left with a pile of acid waste and some of the metal left over. But there's still some metal left in that waste as well. So at Maverick Biometals, we're pioneering bioextraction. We've developed a semi-synthetic enzyme that basically goes in like molecular scissors and breaks down the rock. Now, how does this work? So the first process is comminution. This is standard in the mine. So we're going to fit right into the current value supply chain. So the rock is ground up into a powder, and that's like it's done for acid roasting. Then this is where our enzyme comes in. We're going to take that rock, and instead of heating it up to 1,000 degrees Celsius, we're going to put that rock in a tank of water and add our enzyme in. It's going to operate at ambient conditions. It's going to be a moderate pH, and then that rock completely dissolves. So the enzyme comes in basically like molecular scissors, breaking apart all the bonds. So not only are we going to be able to extract the metal, but the bulk of the rock that's waste is actually now a sellable byproduct, which is like an orthosilicate acid, things for like those little packets you get and stuff to keep things dry. That's one of our byproducts. So we see around a 97% extraction efficiency as compared to acid roasting. You're at around 70 to 85%. And then we'll have complete metal recovery, right, as well as that orthosilicate acid. So there'll be no waste tailings piles. So bioextraction, it's green and more effective. We have higher recovery rates than the traditional acid roasting. We use lower energy because we're not having to heat that rock up to 1,000 degrees Celsius. We're not going to produce that waste pile. Everything's going to be commercially sellable. We're going to use minimal water. Now I said that we're putting everything in this big tank of water with the rock and the enzyme, but we're going to recycle the water and keep reusing it. And then obviously a lot more safe for the workers because it's simpler equipment. We're not dealing with these high temperatures or harsh chemicals. Right now we're working with rock that contains lithium, nickel, cobalt, rare earth elements, as well as uranium and thorium. So our enzyme is not specific to a metal, but rather the rock. So we break down the rock that encases the metal, and then it liberates anything inside of it. Currently, we've proven this out at lab stage, and in the middle of next year, we'll be scaling up to a pilot scale facility that should produce around 100 kilograms of lithium over 12 months. Now, the future of bioextraction is going to be able to frack like we do for oil, but for metal. So imagine mining for lithium with no open pit mine. Simply frack like we do for oil, pump in the enzyme, dissolve the rock, and then pump it out. No open pit mine, low OpEx and CapEx, and low environmental disturbance. So that's going to be the future of bioextraction after we simply fit it into the current value chain in the mining industry. Thank you for your time. We're based in San Antonio, Texas. And another note, we went through Y Combinator last summer. We're currently raising another round if anyone's interested.
Perfect. Perfect. Thank you so much, Jesse. All right. So just to give the rundown, just in case anyone doesn't know, we'll answer questions in order of hands raised on Zoom. So if you want to ask a question, feel free to click the little hand raise icon. It's under reactions on your Zoom bar. There we go. Han is always quick on the draw. Han, go right ahead. You go first.
Right. It's a race, right? No,
Oh,
just
yeah.
kidding. Well, great presentation. Actually, you have a great solution there. I really appreciate it. Just a quick couple of questions here. Could you touch base with the cost and the time compared to conventional traditional process method, please? I mean, I really liked your solution. So
Yep, thank you, Han. So in terms of time, acid roasting will take around 4 to 12 hours. Our process, we expect to take 1 to 2 days. In comparison to traditional biomining, that can take anywhere from months to copper biomining, which is 5 years. So one thing I didn't mention too, we have some mining partners that we're working with, some major mining companies, and kind of that 1 to 2 day mark is all right with them because we have these higher extraction rates. In terms of cost, we expect to be at cost parity, if not a little bit better at scale, and a significant lower CapEx for a full facility.
but you said your cost is better, you said?
Right now, the cost is at parity. We expect it to be a little bit better.
Oh, okay, great. I mean, you're just still doing a lab testing, lab in development area. That's great. Yeah, yeah, I'd like to have a chat with you later, maybe. Thank you.
Thanks, Han. Julia?
Hey, JC. It's pretty interesting. I'd love to learn more as well. I have kind of 3 technical questions. The first one is, do you need finer combination, especially finer grinding? The second one is, how do you scale enzyme manufacturing to be able to service entire mines? And then the third one is, what's the development timeline to engineer the enzyme, since you're targeting the rock, not the metal, for each specific mine? I can repeat those if needed.
Yeah, great question. So you're about scale.
Grinding, scaling the enzyme production, and engineering the enzymes.
So right now we're working with 150 microns, and that's the standard for lithium spodumene. So that's what we're working with. If it is ground finer, it'll work faster, but we think 150 microns should be fine. So that industry standard. In terms of scaling fermentation, we're going to work with CMOs, so contract manufacturing organization. They perfected fermentation. We're just going to do some fermentation for the pilot testing and for our current testing as well. But when you get to large scale, you just got to go with the CMOs that have that perfected. So they'll just lyophilize the enzyme and ship it to the site.
Makes sense. Okay.
In terms of developing an enzyme, so we can get into the weeds a little bit. The quick answer is we're not developing an enzyme for each specific site, but rather for each specific mineral. And specifically for the crystal structure. So there's a few different types, mainly focused on silicate ores, so phyllosilicates, ionosilicates, tectosilicates, and amorphous silica. And so we'll develop an enzyme for each of those specific mineral structures. And then it doesn't matter kind of like what metal is inside, because it breaks down the silica backbone of the rock. So there might need to be some fine tweaking for each mineral, but we're talking magnitude of less than a few months to do that. So we already have basically a big library of starting enzymes.
Interesting. I don't see any other hands up, so I'll ask, like, how do you do the downstream processing? How is the separation or the recovery of each metal? once it's been leached?
Yeah, great question. So yeah, it depends on the rock and the metal. We're innovating on this, breaking down of the rock side of things. And so, we don't want to pile too many innovations in on one. And so we plan to use a variety of different chelating technologies. And so we're exploring them all right now, deciding which one is best for which rock. On the lithium side, there's a few options. We're exploring some DLE technologies. And then for the transition metals, we have a method we think works best. It's a pH tighter filter, also exploring some membrane technology. And then there's a few others. We don't need to get into the weeds and the technicalities there, but we basically plan to build this modular system. So you break down the rock, and depending on what the metals are, you just put all the filters downstream.
Got it. How much are you raising?
We'll raise about 10 million. We raised about 4.2 last year.
Thank you.
Perfect. And I think that's just about all the time. So Jesse, thank you so much for the presentation, and feel free to leave. There's on the chat, there's a way to contact just the hosts and panelists. So if you want to leave an email there, feel free. If you want to give it to everyone, also feel free. It's up to you. Just know that the option is available, whichever way you want it. And yeah, thank you so much for the presentation. All right.
Awesome. Thank you.
Absolutely. Next up, we have Dasco, and presenting from Dasco, I believe, will be Scott. Scott, the floor is yours.
Thank you, sir. Let me see if I get my screen up.
Yep, take your time.
Oh. And you see
We see your screen, but we see everything, like your desktop.
Let me try that one more time.
Sure.
Any luck there, Asher?
Yeah, I can pull it up from my end. You want me to pull it from my end?
Yeah, try it if you can. I don't know what's
I have
going
it. I have it.
Okay.
It's up.
Okay.
Just give me 1 second to full screen it. Bear with me, everyone. All right, I think I got it. And let me see if I can give you the ability for slide control. Okay. See if you can control the slides. Just go back and forth because I think I gave you control.
I'm not moving them.
They're not moving? Okay, so just say
Nope.
next slide, whatever you need.
I'll do that. So thank you, and sorry for the technical difficulties, folks. My name's Scott Ensminger, and I'm with Dasco Incorporated. I want to talk to you today about our use of biochar as a biogenic water remediation tool in general. Next slide, please. So what is biochar? Biochar basically it can be any organic material that's been thermochemically converted to essentially a high carbon material. Next slide. And why is biochar interesting once it's been converted into this material? Well, biochar has a lot of very interesting chemical and physical properties that make it almost an ideal material to be engineered to create adsorptive mechanisms for a lot of specific end uses. It's also a solution to get rid of some waste stream problems. And in our experience and in our technology, it's been very effective at our targeted objectives. Next slide there, Usher. I'm going to talk a little bit about the difference between biochar in general and our branded materials, EBC. Biochar has been effectively and very much over promoted, I believe, since the early 2000s when it first came on the scene and was being noticed. And fortunately, the science is now beginning to catch up to the potential and the reality of its value. And that's DASCO's objective, is to engineer economically and ecologically advantaged vertical products from biochar. The raw material is highly variable and inconsistent. Once we engineer it with our process, we can improve on that. Next slide, please. And so what are our objectives in the conversion of this material? Right now, it's for water quality, both for water safety, removal of nitrates and nutrients in water, as well as PFAS. The first material we'll talk about here in a moment is specific for nutrients, and we can use that material to reverse and prevent eutrophication, Gulf dead zones, algal blooms, things of that nature. And about everybody's heard of PFAS probably. It's recently been found to be in about 45% of the taps in America today, and I think it'll be more than that when the research is finally completed. We think we have a solution to help with that problem. Next, please. Challenges with the current treatment options that are available are efficacy, cost, and oftentimes the creation of a new waste stream when we do some of the remediation. Natural carbon-based alternatives have some advantages and highly effective. It can be reused as a beneficial soil amendment in the case of the nitrate and phosphate removal tool. It's very cost effective, and biochar is a carbon negative material that offers the possibility for carbon credit. Next slide, please. Some of the circular economic benefits of biochar. Initially, we can repurpose waste streams that are problematic and are expensive to deal with. We create an excellent remediation tool that has a vertical product with the material. Post-use, when we use it for nutrient removal, it's an excellent agronomic amendment, and again, the carbon negative opportunity. Next slide, please. Some of the waste streams that we can utilize include beetle-killed pine in the West, which is an extraordinary situation. The mountains of waste wood that's piling up around metropolitan areas today. And another interesting one is railroad ties. We can convert railroad ties in our process, remove the polyaromatic hydrocarbons safely, and create a product that's useful for remediation with the material post-pyrolyzation. Next, please. Specific solutions that we're working on right now. The first product is EBC 5280. It's for nitrate and phosphate removal in water. Currently, we are getting about 6x better absorption than most anything else we've tested against. So it's excellent efficacy. The nitrate version can be regenerated multiple times on site, offering cost-effective use of the material. And again, post-use soil amendment and carbon. Downstream market channels include potable water, wastewater treatment, stormwater, and agricultural runoff. Next, please. The second product that we're focusing on right now is EBC 5281. It is in early development. It's a TRL of 2 right now. It's highly effective at the absorption of PFAS. In the lab, we're getting over 94% absorption on a variety of different polyalkyl substances species. It is a natural material. It's inexpensive. It's effective. And we are working and think it has the potential to be used as an in situ remediation tool in a nano model, where we can put it into groundwater flumes and effectively stabilize PFAS in place, which would be a great economic advantage. Next, please. Some of the economic benefits. Biochar has a distributed value chain and creates a circular economy. Obviously, this is a little redundant. We can repurpose materials and we can pyrolyze just about anything that's biological. Sewage sludge, manure, crop residues, all kinds of different things. And it's a very effective remediation tool because we can engineer it so significantly due to its surface properties. Again, the agronomic and the carbon opportunity. Next, please. A little bit about DASCO. We are a distribution company. We import and distribute agriculture and industrial inputs, and our key focus these days is on the technical development of materials for commercialization. Next, please. brief look at our team. There are 4 key people on the team. I work as an innovation director, and the other gentlemen serve in various portions of the development, commercialization, and distribution of our materials. Next, please. Dr. Eric Vendella at Desert Research Institute functions as our principal investigator in our water chemistries division. He is a widely published and widely recognized expert in water design and engineering chemistry. Next, please. The ask, why are we here today? We're very interested in the opportunity for an MOU with the United States Air Force. We're looking for collaborative opportunity on USAF installations for nutrient removal in waste streams, and we're very interested in the possibility of working with USAF for PFAS remediation on some of their bases. We're also open to investment focused on long-term environmental and economic solutions. Currently, DASCO is self-funded, but we do see the opportunity for very, very significant growth that will likely come very quickly right now. Next, please. Thank you for your time. Those contacts will be available, and I'll also add emails in the chat.
Awesome. Thank you so much, Scott. Han, the floor is yours.
All righty, thank you. Hey, great presentation and great solution. Just got a quick question here. First of all, you have a intellectual property filed on this one, correct?
We do, and we do work on the intellectual property in conjunction with Desert Research Institute on these materials. We've decided to maintain the EBC 5280 and the 5281 as trade secret at this point. We have not filed for patents on those.
Oh, okay, got it. And another second quick question. I don't want to take up too much time here, but can you touch base on your advantage on biochar? I know biochar industry pretty reasonably well, but I know biochar. One of the problems is that actually it's a oxygen sink, right? So could you elaborate a little bit more how you avoid that and what's the advantage of that? I get that, but I didn't quite catch the actual technical side of it. I mean, you don't have to get into too technical, but in big picture, please.
Yeah. So essentially, what we do with the material is we are selecting for specific oxygen and functional groups on the surface of the material in order to create the specific absorption properties of it. The question about it being an oxygen sink, that is true. It does have the potential to be an oxygen sink, and it will oxidize in the soil and in the air. To the extent that it does that, and what that really means relative to how it will persist in the environment, what unintended consequences it might have, I don't think the work's been done to be able to truly, genuinely measure that. That's something we were interested in, but today I can't really answer you to exactly what that value and what that truth is.
But you do have advantage in the market, of course, right? In that respect,
So,
right?
yeah, what we've
Sound
done
like
with,
it.
you'll find with biochar, virtually every other marketing product out there is trying to use raw biochar as mostly an agricultural amendment. We see the value in biochar as a substrate to be converted into vertical products to solve specific problems. And to date, honestly, I don't really know anyone that's ready to go to market with a material that's been specifically engineered for a specific purpose. We don't really believe we have a competitive option out there against us at this time, especially on the nutrient removal and the PFAS removal.
Thank you.
Mm-hmm.
Perfect. Yeah, we have time for one more question if anyone wants to ask. Otherwise, we will continue. Okay, Carolina. Okay, go right ahead, Carolina, and then Maureen or Mo.
Just a quick one. So how does it compare to the existing solutions that are implemented, and what is the cost benefit of using your solution versus what's already out there?
The product from a nitrate and a phosphate absorption as a material is there's really no competitive alternative out there as an economically viable absorbent in that marketplace. Today, phosphate is very rarely effectively removed from waste streams in any way, shape, or form. And nitrates has been a persistent problem for a very long time. The alternatives are high-end ion exchange and or membrane technology, which are very expensive. This material will show significant cost advantages to it, and it has, compared to any other adsorbent for those against those two materials, we're significantly better. We don't have any, we haven't been able to test anything in the lab that's even close to getting the absorption. We're getting over 60% on the nitrates, over 70% on the phosphates.
Perfect. Perfect. Maureen, you're up.
Yeah, so unlike Han, I'm not as familiar with the biochar market, but I was poking around. It looks like, estimates are putting it at about a $200 million market right now. So what's really going to drive? I mean, that's like, So, what's really going to drive growth for the biochar market?
Yeah, that's a great question. I would be surprised, honestly, if it's even worth $200 million today. And the reason for that is many people have entered the market and they're working on assumptions that this stuff's essentially a miracle product and it's going to solve all the problems of humanity. The truth is it really doesn't. When you apply it oftentimes to an agricultural soil as a raw biochar, you can get negative effects out of it, not necessarily positive ones. And so the key comes down to companies that will take the raw material, characterize it, understand what its functional capability is, sometimes engineer it, sometimes maybe not, and create vertical products that have standalone value. In our case, we chose to go after the nitrate and the phosphate first because we stumbled into them first. And we've been working for about 1.5 years to improve the efficacy. We started out with an efficacy that was maybe 7 to 10% removal capability, and we're now in the 60s and the 70s. And so as a vertical product, it doesn't really have a competitive alternative as an adsorbent. Obviously, it's a natural product. It can be reused in an environment, and it can deal with a lot of waste streams. So that's an advantage to it. That's where we're going to scale this thing up into being an economic value that's very significant. I could go really deep into the weeds with you if you'd like, relative to the market potential on this. We have a lot of people lined up that want to get their hands on this. We're already in discussions with 2 distribution companies today, and we think the sky's the limit.
All right, Kathleen, you're up.
Yeah, just a quick, it sounds like the supply chain has worked out because you manage some of this waste, but what is your progress on commercialization? Like how many kilotons a year could you make tomorrow?
So, long-term commercialization. The first, and so the production of biochar doesn't weigh anything. And so the idea of shipping this stuff all over the country is a no-go. That's not a logical way to set it up. So the development, the creation of the manufacture of the material itself is a modular design with our partner in Colorado, where we can take the manufacture of the biochar to the biomass, and we can also take the conversion technology to the biomass and create materials from a specific source material. As far as supply side economics on that, we have one particular manufacturer that's able to make this stuff at a very high rate for us, and we're negotiating with others now to be able to repeat that process so that we have adequate supply. As far as market potential goes, right now we have 2 very lively downstream opportunities, one in stormwater, one in agricultural drainage and runoff. We're working on distribution agreements with those folks. And so we expect to be able to, with a typical unit, we'll be able to manufacture about 10,000 tons annually per site. And with the demand projections in stormwater and nutrient remediation for eutrophication alone, that's not that much material. So we expect the demand to far exceed the production capability for a number of years.
Perfect.
If I failed to answer your questions to your satisfaction, or you have any others, I'll leave my email and please contact me, and I'll be glad to try and answer them as best I can.
Perfect. Perfect. Thank you so much, Scott. And thank you. Yeah, it was a great presentation.
Thank you all.
Next up, we have Jaker Tech, and presenting from Jaker Tech is Mark Jaker. Give me a second because I will be running. If there's any hiccups in terms of the slide running, I only have myself to blame. Let's start there. So I'm running the slides for Mark, so let me get them up. Mark, whenever you're ready, I believe that you should be able to see the screen.
All right, we got video. Okay. I'm Mark of Jakertech. We started thinking that batteries did not have to be wet. And if you could mix active components in the binder resin and still get ionic conduction, you could injection mold dry batteries faster and cleaner. Turns out to be mostly true. And they're now called solid state batteries. This is not a straightforward path. First hurdle for us was not how to make solid state batteries, but what recipe to make. We needed to find a demonstrated chemistry, then everything else would fall in place. The idea is to use existing injection molding facilities anywhere in the world, and there are tens of thousands that have a certain level of technical savvy and discipline, like ISO, ITAR, 13485, or medical suppliers, or automotive suppliers, I'm sorry. The business model idea being somewhat akin to Uber or Airbnb. The facilities already exist. Almost all are job shops, and they're always looking for work. It's almost a plug and play concept with some processing nuances, of course, for these materials. You do not need a dedicated battery facility, let alone a gigafactory. Our manufacturing footprint is ridiculously compact by comparison. Just the idea of using existing resources, it is greener. Our partner is Purdue University, a battery firmament. They have an over-the-top chemistry department and the Viper group headed by the legendary Dr. Vilas Pohl. Our first chemistry is the lithium metal solid state battery, currently with 350 to 400 watt hours per kilo capacity. That is firstly super safe, long lasting, cycling, with a huge operating temperature range, -40 to +500 degrees. It's flexible, tested, validated, published 2 times in Elsevier, and ready to go. It turns out that Purdue is one of the best electrochemistry schools in the world currently. So while lithium ion batteries are sort of me too chemistry today, lithium metal goes farther up the ladder. Next, we are also going for another Purdue recipe, lithium sulfur. This is the 450 to 600 watt hour per kilo range, with the theoretical potential being the highest known at 2,600 watt hours per kilo. Keep in mind that Tesla is currently at 272. So every chemistry we're looking at exceeds anything that Tesla has published or produces currently. Lithium metal might get us to electric aircraft, but lithium sulfur most certainly will. Once again, it's safe, high energy, reliable, high cycle life, and tough. In addition to our near-term offerings, we intend to, are you going to flip to the next slide? Oh, whatever. Thank you. Okay. Near-term offerings, we intend to add other chemistries in the future. We are not a one-trick pony like our competitors. We plan to offer several chemistries. We are a manufacturing technology, and we are a logical manufacturing evolution. Injection molded batteries, solid state in this form, has the lowest CapEx and therefore the highest ROI, and we can manufacture almost anywhere in the world. No site location, design layout, sewer, water, construction permits, electrical supply lines, roads, rail sidings, greasing local authorities. It's all been done. It's ready to go. Unsurpassed interfacial fusion with high heat and pressure. So there's no dendrites, making us the safest. Fewer steps, fewer components, lower weight, lower costs. We're tougher with an elastomeric fluoropolymer electrolyte with huge temperature range. Basically means space batteries. We can do conformal geometries, just like any plastic part you look at out there. We're patented. The market's $300 billion and growing at about 11% plus per annum. It'll be 600 billion here soon. Any questions? Give me a holler. Happy to chat.
Perfect. Thank you so much. It looks like there's a few questions already. Carolina, it looks like you're up first.
So many questions. Yeah, we see a lot of batteries now. It's a very competitive market. So I guess first question would be, how are you? How are you better than others? What are the efficiencies? What is the life cycle? What is the cost over the life cycle? How are you gonna scale? So you don't have to answer all of it, but
Okay.
how are you gonna scale faster than others? How are you gonna outsmart and be better than your competition? Yeah.
All right. Well, I've been in the injection molding and tool and die business, mold construction, for almost a half a century. I'm a seasoned person. My original intent was to bring battery production back to the United States from China. And so with this method, I think I can blow Chinese cost to the weeds. They have low labor costs, but they can't compete with this methodology. We have fewer components, we have higher speed, we have, there is no cast wet electrolyte. This is dry. So instead of hours drying time for electrolyte, we're seconds. We're not going to produce single cells. We're going to produce battery packs. Once you have control of things in high-speed automation, of which I also have a degree, you don't let it go. You do it all the way through. And injection molding components can do the complete pack. That's 8,000 cells. I think are typical Tesla battery pack. We can do that in probably 4 minutes. Tesla, Panasonic, they're clueless about where this is actually going. And it can only be done because we're taking the solvent out of the equation.
Would you, sorry, just to follow up, would you require like building factories?
No. That's the point I mentioned. They're all existing injection molding plants. There's tens of thousands around the world. There's 4,000 in the United States alone. Probably 1,000, 25% of those are ISO or ITAR certified facilities. That means they have traceability of raw materials. They have all the discipline. They have controlled environments, closed loop processing. They're basically ready to go. So the biggest single thing that needs to be attended to in solid state battery is the oxidation of lithium. Okay, it corrodes very, very quickly in air, in particular humidity. So when you're doing this, you're doing it in a dry room, and it's all contained within a work cell. You can, and it's multi-shot molding. I don't know if you know about two-shot molding. Ever see a drill with a rubber handle around it? Yeah, that's two-shot molding. You got a nylon case, oftentimes glass-filled nylon, and you have an elastomeric rubbery grip. That's two-shot molding. Well, you can actually do several shots. You can bring barrels in from multiple directions to that mold, and you can back it off, and you can spin. Look at the Jakertech website, and you'll see injection molding and multi-shot processing, and you'll get a flavor for where this goes. We can insert mold, so we can take and load the current collectors, aluminum, copper, at both ends, and mold the electrolyte against it. And we'll do this at 2,000 to 40,000 PSI range, typically about 8,000 to 10,000 injection pressure. So it exceeds any adhesive glue on Earth. The fusion is incredible.
Yeah, I have more questions, but I'm not gonna hug the
Well-
mic. Yeah, thank you.
Well, you just email me or whatever.
Yeah, so you guys should sometime speak. All right, Gus, you're up.
Actually covered a lot of the questions I had there. I was mostly just going to ask about the data and any publications or more information you can share, but I think maybe it's best just kind of given everything you explained to follow up offline and kind of take it from there.
Sure, but you can go to Viper Group at Purdue University and you'll see publications from Elsevier and room temperature solid state batteries. And you'll see 1,000 cycles with 0 dendrites. Theoretical capacity, I don't know, 10, 50,000 cycles. If it doesn't degrade, how long will it go? We don't know. That's help me find out. It's high. It's astronomical. It's very
Gotcha.
high.
Gotcha,
I don't
that's
know
great.
what the limit is. I can't tell you really.
That's great. No, I can do some, I can look up into the publications. Thank you.
Perfect. Julia, you're up.
Hi, Mark. It's super interesting. It's always great to hear about, really great disruptive ideas. I just want to down click a little bit on quality control, especially. So it's really impressive that you're able to make whole battery packs basically in one go without the multiple steps. But obviously the benefits of multiple steps is you can do quality control at every step. So how do you ensure quality control, especially if you're distributed over many different injection molding facilities? I'm thinking, of car companies or any customer, wanting to do factory visits as a last step to ensure quality before they give you the purchase order and things like that. Like, how do you make that happen if your manufacturing is all over the country or the world?
Well, first of all, as I mentioned, there's a requirement to get in the club. And that is ISO standard certification. So if you're ISO 9001 certified, or you're ITAR, which is International Traffic of Arms registered, or if you're 13485, which is medical, or automotive, Ford, GM, Ford, Toyota, Honda, you have met a certain criteria level, and you are being audited every 6 to 12 months by an outside auditing firm. So the baseline is already there for your protocols. You have traceability of raw materials. You have closed loop processing. Your machinery is not falling apart. You don't have dirt floors. You have a contained air-conditioned plant, not for people comfort. A lot of people don't realize that it's actually for processing engineering grade materials like nylons, which are very sensitive to humidity. They have to be below 1% humidity level, or you're molding junk. You'll get something called splay. It's jetting, and you can see it right away, and there'll be a fracture point when you pull the part out. If you mold it dry, nylon is very brittle when you first get it out, and then you reestablish it. That's just to mold it. It has to be dry. Then you add water. You put your parts into a cardboard box with a poly liner. You pour a cup of water into it, and you let it set for 2 hours, and you can now drive an Abrams tank over it. You can fire projectiles at it. It's just 40,000, 60,000 PSI flex modulus. I mean, it's the toughest stuff in the arsenal, for example. And there's a lot of engineering grade materials that have that sensitivity. So if you're making automotive parts, you're probably molding nylon. Look under the hood. There's nylon all over the place. Polyesters, they're all super tough materials. And this is well within that range of processing and quality control. It's at the highest level. And medical grade, of course. You have to have traceability of every lot, in and out of the plant. It's stellar. And ITAR, the Department of Defense, doesn't take second seat to anyone. So, yeah, it's going to be automatic, high quality parts. In fact, you don't have to find the plant. You don't have to train these people. The staff is already there, and they're looking for work. So if the electrolyte is dry, let's party. It's just another job to them. I mean, they need to be trained on the nuances of processing lithium. And this is a very clean, very dry process. It has to be contained. because of the sensitivity of raw materials. It's no different than nylon or polycarbonate or polyesters or a lot of them materials. They're all sensitive that way. These guys are doing it every day, around the clock, 24/7, a lot of plants. It's true.
Perfect. Awesome. Thank you so much, Mark. And I think there's a few questions that people want to talk to you offline. So feel free to leave your email in the chat. Yeah, and alternatively, if you don't catch it, feel free to email me, and I'm more than happy to help set you up to speak with Mark.
Thank you very much.
With that, we're moving to the second session. And for the first presentation in the second session, we have Setex Technologies. And feel free to start sharing your screen whenever you're ready.
Hi, Asher. Yeah, Paul Glass is going to be joining us. He has the deck, so I'm sure he's getting ready to share right around 2.
Oh, okay. So perfect. So we have 4 minutes. All right. Let's quickly, since it's the second session, why don't we go around and quickly reintroduce everyone, just in case people are just joining for the first time. That way we can have have some continuity and so people can figure out who's who. All right, so Kathleen, do you want to quickly say hello?
Sure. Kathleen German. I'm a tech scout based in the Bay Area. I'm with Dow Ventures. We invest in strategic materials and chemistry plays.
Perfect. Thank you, Kathleen. All right, Mo, you're up.
All right. Hello again, everybody. I'm Mo Rinkunis. I'm an entrepreneurship educator, an angel investor, and I connect corporates and startups in the food, materials, and climate tech space.
Perfect. Han, go right ahead.
Yes, Han Ko, USACO Group. We are a venture capital company based in global area. We're based out of USA, but we have a strong connection in Asian market, and as a matter of fact, we have an office in Seoul, South Korea. Our headquarters in USA. And what's unique about it is that we have interest in multiple companies from all over the world, actually. And our funding covers up to Series A or sometimes B. Thank you.
Perfect. Gerald, you're up.
Yeah. So hi everyone. My name is Gerald Wang. So I'm from GC Ventures America. So we are the venture arm of a Thailand-based petrochemical company called PTT GC. So we are very interested in polymer-related innovations, and we typically look at Series C round to Series B.
Perfect.
Happy to be here.
Thank you for joining. Next up, we have Rudy. Rudy, you're up.
Hey, all, welcome. I'm Rudy Beza, based at Edwards Air Force Base, and we specialize in the research and development side and test new prototypes. Over. Perfect.
Matthew, you joined at the perfect time. We're going around the room. Quickly introduce yourself when you have your bearings.
Sure. All right. Hey, Matt Cohen of Clean Energy Ventures. We're a venture capital firm investing in relatively early stage clean tech, climate tech companies that can reduce cumulative CO2 equivalent emissions by 2.5 gigatons by 2050. Background mostly in the materials science and engineering space. Sorry for being, I guess, maybe a bit tardy.
No, you're right. You're actually right on time. If anything, we're running, just so everyone knows, we're running a little early. The first pitch was supposed to start at 2, so we're very early right now, which is unusual for us, but it's a happy accident, I guess. Next up, Jonathan Wu, you want to quickly reintroduce yourself?
Yeah, hi, John from ITIC, which is the venture arm of eTree, and basically we're founded about 40 years ago, spinning out company like TSMC, UMC, AUO, like these semiconductor companies, and also working in the JV funds with Applied Materials, and also another Israeli funds that's coming up this year. So mostly focusing deep tech, like material science, semiconductors, and also AIs. Thanks.
Perfect. Awesome. Oh, perfect. Matthew's also joining. Matthew, I know you just joined, but we were quickly introducing the panel. Do you want to quickly say hello?
Sure. Yeah, I'm Tech Sergeant Matthew Bias. I'm out here at Rath Lake and Heath, crew chief by trade. Been doing the innovation space here for about the last 2 years now. I've primarily focused on AR and the operational use case. That's my forte and expertise, but otherwise I just love helping getting after stuff for the warfighter. So that's about me in a nutshell there.
That's awesome. Thank you for joining us, Matthew.
Absolutely.
Okay, Sam, you're up. Quickly introduce yourself if you have your bearings. I know a lot of our panelists are just joining now. I think you're muted here.
Can you hear me now?
Yep.
Okay. Hi, everyone. I'm Sam Kim. I'm the general partner of Danget Ventures. We focus our investments and innovations in the hard sciences or deep tech. A lot of our portfolio companies kind of are in the advanced material semiconductor space, but really any innovations in hard sciences we're interested in. We typically like to bring in a corporate venture partner into our deals. So every one of our deals has a corporate partner. We have a strong network and good relationships. So I'm excited to see what Deep Tech Showcase has to offer today.
Awesome. Awesome. Tim, you want to quickly introduce yourself, or we're just going around the panel?
Sure. Yeah, happy to. So Tim Jones, located in Fort Collins, Colorado, part of Innosphere Ventures. We've been running an incubator, B2B science and tech for over 25 years, as well as we have a venture capital arm that invests both domestically and then also internationally. At a very high level, we invest in clean tech, B2B SaaS, as well as life sciences companies.
Perfect. Perfect. Thank you for joining. All right, Addison, you're up.
Thanks, Asher. Addison Amer, one of the senior portfolio managers with the Aon's Advantage funds. We have a focus on providing growth capital in the form of a loan with companies that have strong IP, and look forward to the presentations today.
Thank you for joining us, Addison. All right, Tobias. You want to quickly introduce yourself?
Yeah, I'm Tobias. I'm with M Ventures. M Ventures is the corporate VC arm of Merck KGaA, Darmstadt, Germany. So this is the German science and technology company doing both pharma, life science, as well as semiconductor specialty materials. So pretty broad, and maybe worth mentioning that we're basically the different, not the Merck in America, which is though related to us historically, but the business is separate. And we're doing early stage, usually through Series A, 1 through up to $10 million tickets.
Perfect. Perfect. Thank you for joining us, Tobias. Nilesh, you want to introduce yourself?
Yeah, sure. Glad to be here. Nilesh Trivedi from here from the Bay Area. Under a manager fund called J Ventures. We are sort of stage and sector agnostic, about 70 million in capital across an impact fund and a core technology fund. Happy to be here.
Thank you for joining. All right, Jan, you're up.
Yeah, hi everyone. I'm Yuan from Hypertherm Ventures. So we are, a corporate VC under Hypertherm, which is a global leader in industrial cutting. So I've been focusing on early stage companies for Industry 4.0, including robotics, AI, machine learning, industrial IoT, AI, AI, machine learning, additive manufacturing, materials, and sustainability. So going from C to Series B. Yeah.
Perfect. Thank you for joining us. All right. I'm sorry for any panelist that joins in the next half a minute. We're gonna move forward, but thank you everyone for introducing yourselves and joining. Now we have Cetex Technologies. I believe Paul and Barak are going to be presenting.
Yeah, thank you so much. So Paul Glass here from Cetex Technologies. I'm the CTO, and I'm joined by my colleague Barak Aksak. So together we're the technology leads here at Cetex. So let me see if I can share my screen and go from there. All right, everyone can see my deck here?
Yep.
All right. Oh, well, thanks so much for having us. It's great to be speaking to all of you. And let me dive in here. So Sedex Technologies, we're both a consumer products and industrial product market. And our core technology addresses unmet needs in both of those spaces. So on the consumer product side, there's a need for materials that provide comfortable, reliable grip in wet or sweaty or oily conditions. And on the industrial product side, there is a need for materials that are clean, that are removable, that are reusable, that are high temperature resistant, and are tunable across a number of verticals like automotive upholstery, semiconductor, medical tapes, part mounting, and so on. We have 2 websites, so while we're talking, if you want to browse our website or after the call, you can see us at sedexgrip.com or sedextechnologies.com. So we've developed solutions to these unmet needs by looking towards the gecko lizard. So Barak and myself and our team have been studying this problem and these materials for over 15 years now, going back to our time in grad school. But to look at the question of how do gecko lizards stick and climb? And they do so, here's our friend the gecko on the left side of the screen, supporting its entire body weight just with a single toe hair. And if you look at gecko toes under magnification, you can see these really interesting hierarchical micro nanoscale systems. Gecko toe hairs have these 200 nanometer tips at the end of their toes. So when a gecko puts its feet up in contact with the surface, all those little nano hairs, they bend, they adapt to the surface at such a short length scale that you get intermolecular attractive forces between those nano hair tips and the underlying surface, which are fairly weak in magnitude, but if you get enough points of contact, you can get a significantly strong adhesive system like the gecko has. So we've developed and patented a number of methods and materials that leverage this gecko-like adhesion. On the bottom of this slide, you can see a static image and a video of our products in action, where you can see this dry, repeatable, reusable adhesive quality. So to produce our materials, we have a number of different products, but they all leverage the same core manufacturing IP, where we've taken methods adapted from the semiconductor manufacturing industry, and we can etch silicon into very highly ordered, predictable, high yield arrays with controllable diameter and spacing of a cylindrical unit. And we can take those silicon arrays, bring them to our lab, replicate them with soft materials, and do additive manufacturing processes that are highly scalable and high yield to control the tip shape, the base shape, the angle of those microstructures. You get a template that has very controlled, very predictable, very tunable adhesive or frictional properties. Once we have that template, we can cast a negative of that template and integrate that negative into conventional tool surfaces, like an injection molding tool cavity or a roll-to-roll, a mold that's wrapped around a roll-to-roll embossing wheel, for example. And so on the bottom of the slide, we show how we can produce tape through a roll-to-roll method of our microstructures that have really specific defined adhesive properties. Our products have very specific value propositions that address those needs in different markets. Our dry adhesives are repeatable, they're sustainable, they're reusable. So we have data here over 1,000 of peel and unstick cycles, where we maintain about 80% of the original peel strength. And you contrast that to a conventional tape, tacky pressure sensitive adhesive that might work once or twice, but it's very quickly going to wear out. And so for a number of applications that go through a ton of tape, we can provide a huge value add, both in terms of reducing the cost of that application, as well as improving the sustainability. So there's a really significant move towards that. Also, because we're using fully cured materials to form our pressure sensitive adhesives and not lightly cross-linked tacky tapes, we can produce our materials from elastomers or polymers that have good temperature resistance. So we can provide tapes that work over a much wider temperature range than most conventional adhesives, as well as have good chemical stability. Our grip materials, showing some data here on the bottom right, maintain really excellent coefficient of friction in dry conditions, as well as wet and oily conditions. You can see the data here in red is our Cetex materials contrasted with a smooth elastomer made from the same resin in black, which has good adhesion and good grip in dry conditions, but loses performance in wet and oily conditions. It's a huge addressable market for our materials. In the Q&A, if anyone's interested, we can go into relationships we have in a number of different verticals on the B2B side. Mounting and handling, for example, flexographic plate mounting. Semiconductor, we're looking at applications for back grinding and dicing tape, wafer handling. Medical, we have a commercial product in skin grip. We're also working on skin tape application. We have relationships in the wearables and apparel space as well. We're also generating short-term revenue through our consumer product business. So we did just about $1 million last quarter. We launched this consumer product business in Q1 of 2020. So our short-term revenue is driven by our consumer sales. Our long-term growth we see coming from the B2B business. But definitely very exciting to validate the technology and get that immediate feedback. Our team is a great mix of both technology expertise with myself and Barak and our engineering team. Our CEO, Nick, unfortunately couldn't make it today, but he's a serial entrepreneur, has a lot of expertise in a number of spaces. And we have consumer product expertise, both at the marketing and sales level, as well as on our board. So different ways to partner with us. We are fundraising right now. We have an open $1 million bridge round, as well as a $10 million Series B. We've closed on about 5 million of that Series B. We have about 3 million more soft circled. The $1 million bridge we're looking to bring in the next 1 to 2 months to give us more runway while we finalize that Series B. We also have a number of strategic partnerships within our target market, so we're always looking for more of those. You know, we're open for joint development agreements, NRE licensing models, all open, and customer relationships as well. So thanks so much. Happy to dive in more detail in the Q&A.
Perfect. Thank you so much, Paul. And just to let everyone know how it works, and Tobias already knows, but how it works is that simply press in the reactions, there's a hand raise button. And so if you have a question, raise your hand, and what we'll do is we'll get to them in the order of hands raised. So Tobias first, followed by Matt. Go right ahead.
Awesome. Thanks a lot. And always great to see Paul, somebody who uses semiconductor technology, leveraging that for HVM. I'll start there. It's 2 quick questions. The first is for your patterned silicon wafer template. How many times can you reuse that?
Yeah, so those patterned templates, we can reuse those many times. But basically what we do is with the pattern template, pretty much we'll cast that into a more reusable material, like a high durability polyurethane. And then that high durability polyurethane, we can use then to make our commercial tooling. So that original, like we have silicon wafer templates from 2014 that we're still using now to make our consumer product, because we're kind of, we're like using the great granddaughters of that original template to make our tooling. So we very rarely have to go back and touch that original. So they're kind of expensive, low.
I just want to say, yeah, that could be potentially quite expensive, but it's not. That's great to hear. The second part is regarding you have consumer as well as B2B markets that you're moving into. Which of those segments that you showed on the slide for B2B do you see most traction for currently?
Yeah, it's currently the semiconductor space. And we have a number of active projects. Barak, I don't know if you want to go into a little detail on some of our projects in the semiconductor space.
Yes, thank you, Paul. Yeah, so we see the semiconductor because we see the value added. We're looking at industries where we can add value and we can do value pricing, right? Consumables, it's a tough world as far as our technology is concerned, but in semiconductors specifically, the aspect of light, releasable, residue-free, cleanable adhesives specifically for die, assembly and handling, as well as back grinding and dicing applications. We have partnerships in both those fields.
The wafer handling, generally speaking, sort of those tasks in the fab. Okay.
Right.
Interesting.
Right. We have wafer handling as well, right? We also make wafer handling buttons, correct?
Very interesting. Thanks a lot.
All right, Matt, you're up.
Yeah, maybe a bit of a two-part question, but what was the reason for the rebranding from Nano Grip Tech? And I guess related to that, that's a company that has been around for, you know, a dozen plus years or so. Why is now the time to be really excited about what you guys are doing in dry adhesives?
Yeah, thanks. Great question. So yeah, having been around from those early days, you know, we were Nano Grip Tech and we came up with our brand around the material. We called it Cetex, and we started launching it. So we were then Cetex by Nano Grip Tech, and you know, we were there's some products out there that have been around for a while called, you know, Nano Grip or Nanotech or Gecko Grip or Gecko Tech, and it was a kind of a muddy space. So we felt, you know, the brand was getting traction on the consumer product market. And so we decided to kind of go all in, reposition the company after the technology, and go forth, you know, as Cetex Technologies, you know, built around the technology as the brand and as the company name. As for why now, you know, I think the advanced materials, you know, commercialization startup space, it's a long, slow road, and we've made it through several valleys of death along the way, you know, through the non-dilutive grant funding in our early days and really figuring out how to get this technology from the lab to scale. We have a number of really exciting B2B opportunities in the pipeline that I think, you know, with the extra capital, we can really go attack and leverage and scale, as well as our consumer product business. You know, the graph I showed, you know, is really steady growth along the way, with some more capital investing in, you know, automation and higher throughput manufacturing. We're going to be attacking the retail, brick and mortar retail market as well. And I think there's a real opportunity to drive significant growth through both the consumer and B2B businesses now.
Okay, perfect. All right, Gerald, you're up.
Yeah, so just two quick questions. One is about the material you're using for making a product. So do you also use polyethylene or polypropylene to make your product? And the second question is about techno-economic analysis. So I'm thinking about what's your, so how long is the lifespan? I think there's a chart to show the performance change during the lifespan. It's very small change. So how does your cost compare with the incumbent product, and how much longer lifespan that you can provide to your customers? So these are the two questions.
Yeah, so at the moment, we're not making anything from polyethylene or polypropylenes. The majority of our products right now are on the tape side are either polyurethanes or silicones. And on the grip side, primarily thermoplastic elastomers. We're starting to work with silicones as well on that side, and some natural rubbers as well. As far as durability and pricing, it's a great point. I mean, we have an application with a residential glass company where, you know, our product is lasting for months, and so even though we do charge a significant premium, because that product isn't, you know, need to be replaced as often as we would like, you know, the actual revenue from that customer is you know, not growing as much as we want. So the challenge for us is finding the right sweet spot with pricing and reusability. So flexographic mounting tape is a great application where conventional pressure sensitive adhesives mount flexo plates in printing operations, which is a significant global opportunity. You know, current tapes, you know, maybe last 1, 2, 5 cycles at the most. Our customer, which is a global, you know, leading stake in this market, is looking to us to provide, you know, 50 to 200 cycles from our solution, but we'll be able to price it accordingly. So, you know, we'll be able to charge a significant premium, and the pricing we've come up with is one that gives us great margins, and the volumes there are great. So, you know, through our journey, there has been, you know, finding those right applications where we are bringing the right value, and we're also able to attack and capture significant market share.
Thank you.
Perfect. Sam, last question, and then we have to move on.
Okay, hey, Paul, thank you for the presentation. You touched on a couple other companies that are doing this kind of gecko biomimicry adhesive. What is unique about what you guys are doing versus previous efforts, and what kind of have you protected as far as intellectual property is concerned within this space of, gecko-like skin? It looks like several universities have made some efforts and some companies are working on it. So a little bit more color on that.
Yeah, absolutely. So we have a IP portfolio that's about 20 patents deep. It's a mixture of licensed IP from Carnegie Mellon University, where this technology spun out from, as well as our own IP. We don't think anyone else out there can make materials that are as adhesive as ours are without violating our portfolio. So we have specific IP around the shape of our microstructures, which is without infringing upon those, there's kind of a ceiling to how sticky someone else could make a dry adhesive. And we've seen that. There's one, I'd say commercially, there's one major competitor we've seen out of Germany, but their materials are not nearly as adhesive as ours are. And actually, Flexo adhesive tape company that I referred to, they've evaluated ours side by side, both from a performance standpoint, and we're way up here. And they also did a freedom to operate, had a third-party counsel do a due diligence analysis on our portfolio and realized that, we have a much stronger IP position as well. So, we're pretty confident there. It covers both manufacturing methods that are commercially valuable to us, as well as finished products that without those pieces of IP will be hard to replicate what we can do.
Perfect.
Thank you.
Perfect. All right. Thank you so much, Paul. That's all the time we have for this presentation, but it was really good. And definitely leave information to somehow get in contact with you in the chat or wherever you're comfortable leaving it, or direct messaging, whatever you want to do. With that, we're going to move forward, and we have Maren Muxlow from Intrepid Automation. The floor is yours. Whenever you're ready to share your screen, go right ahead.
Awesome. Thank you. Stand by.
We can see the whole screen.
That's okay.
Yeah.
There we go.
There we go.
Okay. Perfect. Okay. All right. Hi, everybody. I'm Maren Muxlow. I am head of marketing and sustainability at Intrepid Automation. So we do automated 3D print technology. We are a startup out of San Diego, California. And just kind of for some context, I don't know what level of familiarity everybody has with 3D printing or additive manufacturing. So its basic sweet spot is something that sits in the middle of the Venn diagram of something that is highly complex and customized. We would like to add for ours something that's also scalable, where you need a lot of them. So you can make items that you can't make any other way. Since we started as an industrial production hardware provider, we started from the industrial end, and then very quickly realized that the hardware and the materials need to be tuned for the application. So that's what a failed 3D print exemplar is. If you don't have the materials and the hardware really dialed, then you just lose a lot of money. It's expensive and it's wasteful. So our niche, what we focused on, is hardware and materials that work together. So we are a DLP process, digital light processing. We've called ourselves modular DLP. So wavelength is tunable. Resins are tunable as well. So it's a photopolymer process. Our software is compatible with any design software that the customer would use. We have partnerships with a lot of different software companies, Materialize, often a few different others that I'll be happy to talk about as well. And our differentiation is that we focus on automation or high volume production. So these are our two hardware units that are in production that have been tested on location and parts in production right now. One of them, the one on the left, is technically in, I guess you could say, pre-release or early user right now. That will launch this fall in October. It has fully automated post-processing inside one of those cells. The one on the right is the large format VAT-based system, which is significantly faster and more accurate than the competitors on the market. So today I'm here to talk about materials, it being the Advanced Materials Showcase, and our main fastest runner material is our casting resin. And so that's a photo when we presented at the Investment Casting Institute International Technical Conference last year. We won the award for Casting of the Year with O'Fallon Foundry for our castable material. This is a bracket, so that's kind of what it looks like. It has a tetrashell pattern, so there's a lot of air in it. So for foundries, it can burn out pretty easily. Our main strength that we're told is the ultra low ash content. I don't know how many of you guys are familiar with investment casting. It's basically like that bracket that you see on the screen. You dip that in like a slurry, put it in a really hot oven. The pattern goes away, similar to how wax would, and then you pour the metal in there. So the advantages of using a 3D printed pattern are actually immense. It's a rugged, robust pattern that you can ship around. The surface finish won't mess up. Like if you touch it, like something like wax, it's not temperature and heat dependent. And it also just kind of for visual effect, you can hold something up like this is what it will look like, right? Which can be pretty impactful. We found out it's castable in any alloy. So the main application for this is weird shapes. Legacy and obsoleted parts also in this way that's coming around, where you can scan either the hole where something was broken, or you can scan the part that you don't have anymore to be able to make a new one and get it out of the original metal, which is an application that we're currently working on right now. Sorry, I think I skipped one. Our other material that I guess I'm kind of going in order of how fast they're being commercially adopted, is this thermoforming resin. And so that's how most dental aligners are made. If any of you guys have used like an Invisalign, they don't actually print the thing that goes in your mouth. They print the mold of your teeth and then thermoform the thing on top that goes in your mouth. And so that has a ton of different applications. Basically anything that's a weird shape, anything that you can like clamshell around something that needs to be protected in a certain environment, right? We have a couple of different commercial partners that we're running fast on this application as well. This resin is an elastomer, like a squish elastomer. So some applications for this would be thermal gaskets, anything that would be cooling. The foaming resin as well we have IP around all of this, and I can send anybody a technical data sheet. I didn't really know what level, high level this would be, and I tend to kind of be like explain it like it's like you're 5, not that's how I kind of like to understand stuff too. So the foaming resin, anything that would be foam. Right now we're developing an application with a backpack company where it's like a lightweight padding. So given that 3D printing does allow you this kind of like complex mass customization, you can have it be very size dependent. For DoD applications is something else that we're having in the works right now. A nylon-like resin, this is kind of like the hard plastic. This would be replacement parts, buttons, brackets, and unique shapes. Again, that kind of custom and complex geometry. This is a quick chart done by Tom Mueller. He's a really respected voice in the investment casting industry. This was presented last year at that same conference I mentioned, comparing our hardware and casting resin to some other competitors. These other materials that we've developed have similar build rates to that. So it's fast, you can build a lot of them, they can all be different to each other. We have very, very robust IP around all of this, 14 granted patents, multiple pending, around both our process, around our materials, around our post-processing processes, and around our quality control. Our resin formulations presently, the ones that I mentioned here, I can send technical data sheets to anybody who's interested in seeing the very specific properties of any of those resins, but they are tuned to work specifically with our systems, which is kind of how it works in 3D printing. The goop and the oven have to be compatible with each other. We are a really asset-light company due to different partnerships. We have several existing with large resin producers and give them the recipe. They can send it to somebody in high volumes. Likewise, we have a large contract manufacturer manufacturing our systems. We don't make them on site here in San Diego. Industry validation, we've won a couple of awards. This picture, I always like to show it because it's from a cool camp we put on last summer called Girl Meets Additive Manufacturing. That's our lead chemist showing some high school girls how our systems work. And that's something that we're really passionate about, is making sure that people know that 3D printing is not a Star Trek replicator. It actually takes a lot more work than that. And raising up the next generation of engineers to be able to help us figure that out. Here's just a quick summary. Industrial scale additive. We started making our own materials and tuning our own materials because we realized that they really needed to work with the systems that we were providing to customers in order to get the best possible product out of these things. Our ask is engaging on projects and initiatives related to either large format production or high volume production. Supply chain optimization, legacy or obsoleted parts, specifically casting applications, because that is our most market validated and testing. We did recently close our Series A last month in this climate, which I think speaks to the strength of our team, that we're really proud of that. Right now, we would be looking for strategics for those of you that are investors on the call, and largely validating some of these other resins and these other applications. Please write to me if you can think of any questions that aren't answered on this call, or if you would like to see data sheets for any of the resins or for our hardware. And thank you guys all so much.
Thank you, Maren. All right, Matthew, your hand's been raised for a little bit already. Go right ahead.
All right. My question is on your guys' resins, because we have a particular use case right now that is looking for a resin that is flexible, that is also capable to withstand extreme heat and extreme cold to go in a cockpit for a throttle cover on the F-35.
Okay.
So, and we've been struggling to find resins that are capable of that. And if you guys potentially have that and have the proof on a data sheet on that, I'd be highly interested to get that to the F-35 community to potentially look into purchase of that material or the printer that utilizes that material.
Okay, that sounds great. If I can get your contact information, I can send you the data sheet over after this call. And then I can also send you samples if you can give me a mailing address. They're fun, like we can the squish.
Absolutely. I'll post it in there.
Great, thank you.
Also, is that material airworthy at all? Like if it were to be put into a travel pod per se and go up to altitude and be in that extreme cold temperatures as well?
It would depend on the temperature, because I don't know that we have tested anything that's of a standard of airworthy. We do have the ASTM standards that we use are the temperature ones. So we do have that data, but that actually would be really valuable for us too. And we're right now kind of looking at a couple of different SBI or STTR topics, and that one sounds like kind of a great one.
I know that's one of the avenues that we've looked at, but we can talk later. I know that other individuals have questions, so I'll shoot you my email in the chat.
Great, thank you so much.
Perfect, awesome. All right, we have time for some more questions. If people want to raise their hands, don't be shy. Otherwise, we can continue moving on. Maren, I guess you just okay. There you go, Han. You're up.
Sorry, late in raising hand here. Great solution, actually, great presentation as well. Could you tell us a little bit about the, do you currently have a revenue then or not?
We do, yes.
You do, okay. What's the size of that?
I think last year it was something around 1.2 million. I think. So don't quote me on that. I would know exact figures.
So your ARR is about $1 million range right now.
Yes. Yeah.
Oh, okay. Got it. Okay, great. Thank you. Just wondering. Thank you.
Perfect. Matt, you're up.
Yeah, curious if you could talk a little bit about the sustainability benefits here, or how you kind of quantify greenhouse gas reductions and how this kind of makes the world a better place. I'm sure there's a story here that a lot of investment casting, 3D printing companies can say, but there might be some uniqueness for you guys specifically. So I guess given your position, curious to hear your take on that.
Yeah, no, that's great. So we are an early member of the AMGTA, the Additive Manufacturer Green Trade Association, and the lead of the photopolymer working group for that organization. And so for investment casting, basically there's a ton of waste in 3D printing, right? It's kind of like the dirty secret of 3D printing is that like when the prints fail, they just throw the things away, right? Or how things are oriented, how the support structures are, like, can you throw those away? Can you recycle those? All this kind of stuff, right? So that's in one avenue that we're pursuing a study about. Firstly, recycling supports. Second, because our hardware is more accurate, you don't have to throw as much of it away. Like there's not like this huge, like half of the prints failed, you have to get rid of them, right? If you only have to throw away 1 for every 100 versus 50 for every 100, that's significantly less waste, less electricity, less materials usage, getting it right the first time, pretty obviously. Second, if you're familiar with the investment casting process, there's a lot that goes into tooling a wax mold. So you have to, make the master, then you have to make this whole entire set of tools to be able to reproduce a wax master for that process that uses a lot of water, that uses a lot of steel, that ships things all around the country. You don't have to do that with our process. So it condenses that supply chain significantly, right? Lastly, just being able to iterate and make a more lightweighted, more efficient design has huge sustainability benefits overall. So if you can design optimize or topology optimize whatever geometry you're trying to make to be able to cast then an end-use metal part, the AMGTA had a study earlier this year where they showed that one lightweighted metal bracket that was not, I guess you could call it like not mission critical on an airplane, just with that being topology optimized, had a significant reduction in the fuel that the airplane would use. So if you can lightweight everything on a plane, you're going to use less fuel, you're going to use less energy, less everything, right? So it's a compound interest story. And we're working on a document that can speak to that more concisely. If you're into it, I can send you our sustainability report or any of the stuff we're working on with AMGTA.
Great, thanks.
Perfect. And I think that's all the time we have. Maren, I think you should definitely, there's one email in the chat for you, but definitely leave your email anyway for the panelists and hosts, as it says in the Zoom box. And thank you for the presentation.
Thank you guys all so much. My email is in the chat. Please reach out if you'd like a data sheet on any of the resins that I mentioned or samples or anything else.
Perfect. All right, next up, we have Alpine Advanced Materials. The floor is yours.
All right, thank you for having me. Can you see my screen yet?
Now I can.
You're right. Oh, you hear me all right?
It's a little, I don't know if for everyone else, for me, it's a little bit quiet. I don't know if there's a way to make it slightly louder.
I'll bring my mic closer and talk a little bit louder. Is it getting better?
Yeah, that's good.
All right.
Yeah, that's better.
So thank you all for having us. It's exciting to be back with Deep Tech Showcase for something that's pretty near and dear to Alpine Advanced Materials' heart, and that is the Advanced Materials Showcase. We feel like we fit right in. A little background on who Alpine is as a company. We are a combination of design and manufacturing, utilizing advanced materials and advanced manufacturing methods. Our core focus is going to be on thermoplastic, injection molded thermoplastic materials, and typically on the higher end of those engineered thermoplastic materials. And what we do with that is traditionally metallic to non-metallic conversion. So taking traditionally metal, aerospace, defense, or otherwise other industry components and converting them to a high performance thermoplastic to reduce weight, increase durability, whatever the need may be. But the core focus has been metallic to non-metallic conversion. And one of our novel materials that helps us do that is HX5. It is a proprietary cutting-edge nanocomposite material. It was developed by Lockheed Martin Skunk Works for the F-35. It has since been carved out, and Alpine is the sole proprietor of the material now. It's a unique engineered resin system. It includes reinforced carbon fibers, so there's a carbon-filled material, and then some other ingredients that make it unique that I'll kind of detail the properties that are unique about the materials coming up. But when you compare it to other high performance thermoplastics, it sits near the top of the extreme temperatures with respect to existing plastics and the highest end of mechanical performance. So to kind of put some data to that claim, you see that pound for pound, it stacks up to be about 80% higher specific strength than 6000 series aluminum, which when this was set out to be developed, the goal was to replace 6000 series aluminum specifically for lightweighting purposes, but also for more environmental reasons, higher durability in salt fog environments, in hot and cold environments. Over its thermal cycle, it is a lot more stable than aluminum or any other thermoplastic material or metal material. Its coefficient of thermal expansion is 1/6 that of aluminum, so it's extremely thermally stable across its thermal cycle. What we can do beyond just the HX5 material to replace, we use the HX5 material to replace aluminum alloys. But to target stainless, titanium, other high performance, lighter weight or higher weight metal materials is a process we have developed with a partner of ours, Allegheny Performance Plastics, called thermoplastic composite injection overmolding, a very brief and succinct title. We abbreviate it as TPC-IOM. Essentially, it's a hybrid solution of thermoplastic materials and high performance, high tensile strength unidirectional tapes. What you see in the image on the right is a combination of about 10 to 12 layers of a high performance unidirectional PEC material overmolded with our HX5 material. And what we're doing here is getting an extremely high strength property out of the unidirectional tape, but utilizing the manufacturing benefits of injection molding, so we can get more complex shapes in a much quicker process, as opposed to going through the process to do high layups or pre-preg carbon fiber materials. The manufacturing process for them can be cumbersome to get complex geometries. And this process marries both and can produce parts in about 90 seconds, typical injection molding cycles. What we've seen with the HX5 material is a superior bond strength with that and the unidirectional tapes. In our most recent test, we actually showed delamination of the tape prior to delamination of the bond between the HX5 material and the unidirectional tape. So that's a superior bond strength. And what we can do with this is replace stainless steel. We can replace titanium, magnesium, all those other higher grade aerospace metals at significant weight benefits, and in some cases, environmental benefits as well. To summarize the HX5 material, it's a versatile baseline material. We can utilize just the HX5 material to get a high strength to weight ratio and replace, say, 6000 series aluminums or other thermoplastics. We can use the TPC-IOM process to increase our strength properties and replace other high performance metals. And another unique property of the HX5 material compared to other thermoplastics is its coatability. It has the highest rated adhesion with functional and decorative coatings. There are ASTM standards for adhesion. Typically 5B is the highest rating in most of the tests that we've run. We've gotten 5B in everything that we've coated with. That's functional for increasing electrical conductivity, increasing your EMI resistance. The material has carbon elements, so it does have a very low level of electrical conductivity, but we can increase that with a coating of nickel over copper or a similar conductive emissions coating. We have done thermal coatings to increase the thermal deflection, the heat deflection of the material, anti-icing for wing structures or anything in an aerospace environment. That is kind of what separates this material beyond the baseline properties of the material, is its adaptability. And what Alpine can do beyond, using this material as such a versatile material is combine it with our unique design process to really overcome any design challenges. Our process is a unique combination of what's called mold flow analysis and finite element analysis. Mold flow analysis is commonly used in injection molding to understand the manufacturing parameters and capabilities of a given part in a given machine. But what we do with it is actually take that mold flow analysis use it to characterize the fiber alignment of material. Remember I said it's a carbon-filled material, and the strength, it's an anisotropic material, so the strength of that is highly dependent upon the orientation of the fibers in the molded part. Well, we can understand and characterize that, export that into a finite element analysis, and now we can run a anisotropic finite element analysis to give us a high confidence, high accuracy finite element analysis to understand, is this part going to perform as required? And that's a kind of a unique process that we don't see elsewhere in the injection molding or the high performance thermoplastics environment. A lot of people that traditionally are using metal materials like the isotropic nature of metals, and going to an anisotropic material kind of gives some people concern or headaches. This process is how we alleviate the concerns from the confidence in the simulation perspective.
1 minute warning.
Thank you. Just giving you an idea of some of the range of complexity of parts that we've done. We've done small, very small, simple parts, all the way up to very large components that either go in engines that are UAV components. We do high sensitivity optics. It's very a wide range of parts that we do. And the last thing I want to mention is injection molding can be difficult to prototype with. We've developed a process where we're 3D printing single-use molds, and we're able to provide injection molded parts with high mechanical performance within usually about 2 weeks. So that gives a customer the ability to take a part in hand, analyze it, test it in their required test, and then iterate if necessary, or go out and produce a production level tool. So with that, I'll leave it up to questions. What we're looking for today is really partnerships with applications or joint developments. We are a funded company, but if there are investment interests, we will entertain those as well.
Awesome. Perfect. All right. You guys know the drill at this point. Han, you're first.
Right. A great presentation, and we love your technology there. Could you tell us a little bit about your ITAR, your flexibility in ITAR? Okay, so working with overseas entities, please.
Yeah, absolutely. So it really depends on the part in the ITAR or EAR restrictions upon it. We do have overseas manufacturing capabilities. It's really up to the application's restrictions when it comes to, do we have to use ITAR limited companies? But we are ITAR registered, we are ITAR certified. We commonly work, honestly, in ITAR or EAR marked parts. That's where most of our production lies. So does that answer the question?
Oh, yeah. And then also one just quick question. Your IPs, right? Are you filed in globally or intellectual properties?
Yeah, I believe so, but I'm not sure. I'll have to, I have your email here. I'm also send a follow-up to
okay, yeah, great. Thank you, appreciate it.
Of course, thank you.
All right, Jeremy, I'll just ask it because it's in the chat, just in case. Matthew from the Air Force asked if you're able to print material that is flexible, that stays flexible, extreme cold and heat, and is resistant as well.
So for this material, we currently don't have 3D printing live today, but check back with us in a month. We are filmatizing the material right now, and then we'll be able to give some identification on the abilities to 3D print, if it's going to be a more flexible material, less flexible, if the fiber alignment's there. That is a live project, but unfortunately at the moment I don't have the output data to share.
Okay. All right, perfect. We have time for one or two more questions if someone wants to be brave and ask. Otherwise, we can move forward. All right. Perfect. Perfect.
Right, thank you all.
Thank you so much, Jeremy. And feel free to leave your contact information in the chat. Next up and last of the session, we have Inkbit.
Thank you all for inviting me. Should I share my screen or are you going to drop?
Absolutely, share away.
Okay, thank you. I didn't realize that. Give me 1 second. Yeah, I think I need to switch. Okay, you should be able. Do you see the right
I see the PowerPoint view of like the editing view, not necessarily the presenting. view.
It's not the presenter view. Okay.
No, not yet.
Perfect. Okay. Thank you all very much for joining today. Thank you for inviting me. My name is Davide Marini. I'm a co-founder and CEO at Inkbit. I'm originally from Italy. My background is in mechanical engineering, but I did my PhD at MIT. So I'll tell you briefly the history of our company. So we spun out of MIT in 2017, thanks to a grant from DARPA, who sponsored the development of our core technology. And as I will explain in a few moments, the fundamental innovation that we bring into the world that did not exist before is the idea of endowing a 3D printer with a set of eyes so that it can self-correct, it can be more accurate, more precise, and it can print with a much broader array of materials. So over the years, we developed larger formats, and in 2022, we started shipping printers to customers. Our business model is a traditional one. We provide complete 3D printing systems comprising hardware, the software, and the materials, and all of this was developed by us. So we built the printers, the materials, and the software all internally. This is an example of an installation for a customer in Nevada. I should also say that we are about to install 2 machines at the US Air Force this year. So what's special about our technology? We named it Vision Control Jetting. In essence, unlike traditional material jetting, which relies on mechanical flattening, we use a vision system to ensure that the machine operates under vision-based feedback control.
Dude, I think we're seeing the wrong screen still.
Sorry?
I think we're still seeing the wrong screen.
Oh, sorry about that.
Yeah, no worries.
Do you see the right screen or not?
Still no. We're on
the first one.
Yeah.
How do I display? Okay, let me do one more thing. Give me 1 second.
Yeah, if you want to just try resharing, sometimes that works.
Okay, do you see the right screen now?
Now I do, yep.
Okay, perfect. So yeah, so this is the concept, the main schematic of how our printer works. It is based on a vision system that was developed in-house, comprising a laser scanner that creates a depth map after each layer is deposited. So the depth map is compared to the CAD file in real time. So the machine can pretty much compare what happened in terms of droplets deposition to what was supposed to happen and react in real time. For those of you who like to go into the weeds of 3D printing, you may already know the PolyJet technology from Stratasys, which is very famous in the inkjet world. So the traditional way of making an inkjet platform function is to use a roller, meaning that after each layer is deposited, one needs to scrape the top portion of each layer to make it flat so that the machine can start from flat every time. That is essentially a mechanical way to providing feedback control. In our system, on the other hand, we don't have to roll or scrape. We rely on vision to pretty much know where to deposit the material. So this opens up a whole new array of chemistries, because on the top portion of the screen, you can only pretty much use acrylic chemistries. In what we do, we don't have to use acrylics. In fact, we don't use any acrylics, which are typically materials that are mostly usable for prototyping. So this is a movie of how the machine works. Each of these modules is dedicated to a material. So it's a natively multi-material format. And here you see the vision system. So the vision system scans every single layer after deposition and creates a topographic map, so to speak, of each layer and compares it to the CAD file. Is the movie visible? Okay, great.
I had a hard time unmuting, but yes.
Great, great. So yeah, so essentially, this is how the parts come out of the machine. On the left, you see a typical build. You may notice that the build density is very, very high. And the reason is because it's a combination of reasons. One is that we have recently announced a revolutionary new packing algorithm that enables us to pack builds extremely densely. But the other reason is that our technology natively enables 3D printing with close packed components. You also notice the gray parts are made of a rigid epoxy. The white parts are an elastomer material based on thiolene chemistry. And on the bottom right, you see an example of showcasing pretty much all our capabilities. And unfortunately, I cannot hand it over to you, but typically we give this sample out at trade shows. But it shows our multi-material capabilities. You see the gray and white. It shows the accuracy. We can print barcodes. We can print threads down to M3, which you see there. And we can print captive elements. In this case, there's a small little bead captive in one of the squares. So in terms of materials, we're just started. Basically, our journey, our commercial journey has just started. So we have this set of materials now in terms of rigid and soft, but we are continuously opening up new chemistries. And one of the asks that I will have at the end of the presentation will be precisely, we will be interested in collaborating on the development of new materials for specific applications. So for the moment, for today, we have a tough epoxy, which called Titan Tough, that is comparable more or less to nylon 12. For those of you who are familiar with SLS, we also have a version of this epoxy that is highly resistant to chemical corrosion. And we are working towards cyclic olefins, which are strong, ductile, and they have an excellent heat and chemical resistance. We have not announced those materials yet to the public, but we will do so by the end of the year. In terms of soft material, we have currently a soft elastomer in 30A hardness. The interesting aspect that everybody keeps bringing up when we are at trade shows is that we're capable of 3D printing soft parts that are also extremely intricate. So we can maintain very high precision. If you were to hold this digital foam up to a light bulb, you would see that the light goes through. So this pore size is about 200 microns, and yet they are very, very finely aligned. So we can make highly precise, highly intricate, soft structure, which is something that one doesn't usually encounter in 3D printing. We're also working on a harder version of the soft elastomer. This was a request from an automotive customer because of the necessity to use seals and gaskets in prototyping and pre-production for automotive companies. So give me 1 second. Is there a message maybe? No.
We just did a presentation.
Let me give you a very quick application example, and then maybe it's better to go to quick Q&A. So underwater applications are something that we're exploring now. This project was done in collaboration with Pliant Energy Systems. This is essentially an autonomous underwater drone that can swim underwater, can also walk on hard surfaces. And so the idea here is to explore the concept of hardware software co-development. So the moment you change the control strategy for a robot, it is important to also change the hardware design. So you need a technology that can keep up with the changes. So that robotics is an industry that we really like. This is another example. This is a traditional robotic arm in collaboration with Haddington Technology from Nevada. So this is again an example of how our technology can enable very rapid development of complex products. Because when you make a robotic arm like this, you need to print hundreds of parts, and they all have to fit together perfectly, which is enabled by our vision system. So what's the vision for the company? We're starting with single material components for robotics, exploiting the advantages of our vision system, our accuracy, our repeatability. But we're also developing multi-material capabilities. What you see here on the top is an integrated gasket. This was again for a robotic component. And over time, I would like to introduce the capability of printing conductive traces as part of the print, and which will be enabled by the vision system. And also, I would like to explore the healthcare market with hydrogels and tissue engineering in general. So what's the ask? I would love to, if there are companies listening today, we would love to co-develop new products with you. We would like to enable your capabilities in rapid product development. And we will also be opening a round of funding in September. If you might be interested in investing, I would love to hear from you. This is my email. And I'm very grateful for your time. And I would like to now open it up to questions.
Perfect. Thank you so much, David.
Oh, no, thank you for inviting me. Thank you.
Absolutely. So as the panelists all know, we'll go in order of hands raised. So feel free to start raising your hands whenever you're ready. And don't be shy. All right, Han, you're up.
Right, I'm not shy, right? Just kidding. Just kidding. Hey, David, great presentation. Really interesting technology. I just want to know a little bit more about your machine vision side of it.
Yep.
I know you give a good explanation, but how you use also, do you use any algorithm for it though to improve the process better? Do comment on that, please? Without, if it's a trade secret, that's fine, but it's a high level.
So the idea of enabling a machine with a vision system to do inline inspection is not new. We did not have this idea. What was difficult is making it work. And the reason why we were able to make it work is partly because our roots come from the computer science department at MIT. So we developed the fastest possible algorithms for basically capturing a depth scan at high resolution in real time. So the machine generates about a gigabit of data per second that needs to be processed in real time. So the optics, the idea, we use essentially profilometry, but all of this has been optimized to work in real time. And we use the fastest GPUs available, and we use some of the most advanced algorithms. We also use AI for reasons of adapting the process to specific materials. So for example, some materials may have a tendency to flow more than others. So you need to take that into account in order to properly instruct the machine. But we are at the beginning of the journey. At the moment, I would say the machine is powered. I would classify this as machine vision, more than machine learning, but we're also moving in the direction of using machine learning.
Good. Yeah, that's exactly what I was wondering about. So you have a great potential there too. Thank you. Appreciate it.
Thank you. Thank you very much for the question.
Absolutely. So we're running 2 minutes over. So we could push it and have time for one more question, but I know some people do have hard stops now. But if not, what you can do is you can leave, David, you should leave your email in the chat, and I'll also make sure.
Let me just put it in the chat right now.
Yeah, exactly. I think that's probably the best thing to do, because I think some people have hard stops, unfortunately. Perfect. Thank you. If someone does want to.
Thank you so much for inviting me. Thank you.
Absolutely. All right. Perfect. Yeah, it looks like a bunch of people, weren't able to stay. But perfect. Thank you, David. Thank you, everyone who joined. Thank you to the whole group. This showcase was really, really strong, really good, very technical. Loved it. Thank you for joining, and stay tuned for next month. We're having an energy showcase. And yeah, feel free to email me if you guys want any updates or if you need to connect with any company here. And it's a pleasure having everyone, the companies and the panelists. Have a good rest of your day.
Thank you. Bye.
Bye-bye now. See you later, Han.
I'll see you later. Thanks. Another good session. Appreciate it.
Absolutely. Absolutely.